Alrighty. So we're going to look at tangent lines and difference quotient. Huge part of the beginning of calculus, whether you're taking it here and you're taking AB or BC, or you're taking it on a college campus and you're taking Cal 1, doesn't matter. Everybody's starting with this because you got to have this because you're going to use it a lot. So we're first going to talk about these two different kinds of lines that we have graphed on our graph right here. So this line that we have right here intersects this curve at this point right here. Well, the way I drew over it looks like it's more than that point, but trust me, it's just that point. Then this pink line, this line right here, intersects the curve at this point and this point. I did a really bad job of those. They don't even look okay. So everything I just said stands. I'm doing the same thing. I'm just going to do it better so you don't have to erase anything. I didn't do it wrong. I just didn't do it well. Let me see. Maybe I'll cheat. That's what I'm going to do. I'm going to cheat. And I'm going to... There we go. I'm cheating for your sake. And then... There we go. Because they were much better last period, but I don't know what the heck was going on here. Okay, so we've got... They both intersect at this point, but then the pink one also intersects at this point. That looks way better than what I had before. Okay, so you were introduced to both of those kind of lines in geometry, and I feel like we've talked about them this year, but this year's been so weird, who knows? Maybe I'm making things up. We have a line here that intersects this curve at one point. It just touches it at that one point, and that makes that a tangent line. Tangent line. Then this pink one, excuse me, intersects at 2 points. That makes this a secant line. So we have secant lines and tangent lines. So the definition here says a tangent line is a line that just touches the curve. So that's not a great definition by any means. I don't know why I haven't changed that, but let's talk about what you learn in geometry, because with geometry, you're talking about these lines specific to circles. You're not talking about them with curves or anything else. So what the definition you're given is that a tangent line is a line that intersects a circle at exactly one point. That is 100% true when you are talking about lines tangent to circles. And it's even 100% true on this specific curve. But let's say, for instance, that we have a curve that thinks it's going to be a parabola, and then it decides, oh, nope, I'm not a parabola, and it does something like that. Okay, so maybe like some sort of cubic curve. Then if I have a line that's tangent, kind of in the same spot, I mean, my picture, I'm doing this by hand, so we know it's not going to be perfect, but, and then my line comes in like that, totally looks tangent, right? But what happens when I keep going? It intersects it again, and depending on the curve, it could intersect it again and again and again and again. That's still a tangent line, because the definition really isn't that it intersects the curve at exactly one point. You're going to talk about being in the right neighborhood and things like that when you talk about points in calculus, and most, or a lot of things that you're going to do is going to have restricted domains. So if I just looked at the neighborhood that this point lived in, like with this restricted domain here, then it only intersects it at one point. Okay, so it has more to do with what's happening right around that point than the graph overall. So in this case, yes, the tangent line intersects the curve at exactly one point. Here, it doesn't intersect the entire curve at exactly one point, but it's still a tangent line because it doesn't, pass through it right there. It's basically just touching the curve. Does that make sense? So I want to make sure that you're going in with the correct idea of what a tangent line is. We can say for a circle at exactly one point, because there's no way for it to be anything else because it's a circle. But when you have curves, things are a little different, okay? All right, so that's our tangent line. So we want the slope of a tangent line to a curve. And if the line only has 1 point on that curve, it's going to be really hard for me to find the slope of that line. Because we know how to find slope. You've been doing that, I think, since before Algebra 1. You know how to find slope. You understand what slope is, but you've been doing it with 2 points every single time. So if I asked you to find the slope of this secant line, you could do that with no problem, because you got 2 points, you know how to find slope. So we're going to use that idea to approximate our slope of our tangent line. If I use this, since they both intersect this line, they both intersect at this point, I could use another point and I could approximate the slope. Well, you can tell by looking at these two lines. If I find the slope of the pink line, sure, it'll be an approximation of the slope of the purple line, but not a very good one, right? To make it better, I could take this point right here, and if I slide it closer, that'll start to turn this line where it'll be closer and closer to the purple one, right? Does that make sense? So the closer and closer this point gets to this one, then the more and more this line's going to have the same slope as the purple one, right? So that's what we're talking about with limits. You want to get closer and closer and closer. So if this point is x, this point, the x value, we say it's x plus h, because we just moved to the right a little bit on the x-axis. Make sense? So if this is x, this has to be f of x, right? Because if this is 2, this would be f of 2. So if this is x plus h, this has to be f of x plus h. So when I move this closer, h is going to be getting close. H is going to get closer and closer to 0 because this is basically x plus 0. You with me on that? So that's where what all this stuff says right here. It says to approximate the slope is still m, just like it always has been. The slope of the line tangent to the function at x, f of x. We use the nearby point that we just talked about, x plus h, f of x plus h, to create a secant line, then evaluate this limit. So let's talk about why that works, and this isn't just a bunch of mess that somebody decided to make up. If we talk about the slope, the big boy and girl way to talk about slope is delta y over delta x, right? Change in y over the change in x. Most likely the first way you learned it was with the actual formula, which is y2 minus y1 over x2 minus x1. All that should look familiar. If it doesn't, I'm very worried for you because I know it should at least look familiar. So let's think about what that means here. If this is x1, y1, and this is x2, y2, then this is y2. So if I'm going to do y2 minus y1, y2 is f of x plus h minus y1, which is just f of x. Then x2 minus x1, my x2 is x plus h minus x1, which is just x. So if I clean this up, these x's zero out, so I'm just left with h in the denominator. F of x plus h minus f of x, is that just going to give me f of h? No, it doesn't work that way, right? So this basically, if you look at it, this is this, which is this. That's where it comes from. It comes straight up from the slope. That's all it is finding the slope of the secant line. But remember, we want h to approach 0. So I'm finding the limit as h approaches 0 of that, and we'll find our slope. Okay, does that help some? So we find the slope using these 2 points, right? We don't know what h is, that's okay. And as h approaches 0, that's going to be our limit, and that'll give us our actual slope. So let's see how this works here. It says find the slope of the tangent line, or the line tangent to the function at the given point. Okay, so we want the slope. When you use the difference quotient, look, the slope is equal to a limit. It equals the limit as h approaches 0 of f of x minus h, so x is negative 3, so f of negative 3 plus h minus f of negative 3, all over h. Everybody with me so far? So now I need to actually evaluate those things. So I'm going to have the limit as h approaches 0. So every time I write an equal sign until the very end, I have to rewrite the limit because it's not just that fraction, it's the limit of that fraction. So f of negative 3 plus h, I'm going to substitute it into here. This is going to give me negative 3 plus h squared plus negative 3 plus h plus 1. So all I did was evaluate that with this function right here. Minus f of negative 3. What's f of negative 3? You shouldn't have to do any calculations at all. Right, but without any calculations, we're going to think smarter, not harder. You're right, but look, if this is negative 3, 7, isn't this x and then f of x? So if this is negative 3, the y value is f of negative 3, so that's f of negative 3. Does that make sense? They basically gave you that part. All right, so that means here I'm just going to have minus 7 all over h. Any questions at this point? All right, so let me make this very clear. Fractions, factoring, and multiplying binomials and trinomials out might be your downfall in calculus. You have to be good at it, you have to be confident in it, or that is what's going to get you tied up in here. Because we're about to do a whole bunch of algebra stuff, and if that's what blows your mind, it's not the calculus at all, it's that basic algebra that's killing you. So I'm going to rewrite equals the limit as h approaches 0 of. All right, so I've got to actually multiply this stuff out. This does not give me 9 plus h squared. It gives me 9 minus 6h plus h squared. Then minus 3 plus h, and then that positive 1 and negative 7, we'll say that's minus 6 all over h. So then the limit as h approaches 0, and I'm going to clean up this numerator here, put it in order. So I have h squared, I'm going to mark it out as I use it. So I got h squared. Especially when there's a ton up there, I mark them out as I go. Then I have negative 6h plus h, so that'll be negative 5h. So I used those. 9 minus 3 is 6, minus 6 zeros out. So that's it for my numerator. Denominator is h. I have a GCF in the numerator. So this is going to equal the limit as h approaches 0 of h times h minus 5 over h. Well, now I can reduce those. So I get the limit as h approaches 0 of h minus 5. Remember, sometimes direct substitution works, and if it works, use it. So I can evaluate this limit by substituting in this 0, and my answer is going to be negative 5. And that equals, back up here, notice the slope was equal to all that limit stuff. This is the slope of the line tangent to the curve at this point right here. That's your slope. What questions do we have? Anything? Okay. Let's look at number 2. Fractions, factoring, and multiplying. I'm telling you, if the fraction stuff blows your mind here, it's not the calculus or the pre-cal that you're struggling with. It's confidence in your fraction knowledge. So we're going to find the slope. That's equal to the limit as h approaches 0 of, this is going to be f of x plus h, so 2 plus h minus f of 2 all over h. And actually, y'all simplified this a bunch in Algebra 2, you just didn't even know it. I know for a fact if you have Miss McWhorter, because when you're doing compositions of functions, she threw in the difference quotient a bunch. You just didn't know that's what it was. But you were having to evaluate and simplify things. You ended up doing that. So I know the process you've seen. You just didn't know why you were doing what you were doing. All right, so then this is going to equal the limit as h approaches 0 of, all right, so f of 2 plus h is going to be 1 over 2 plus h minus, now f of 2 is super easy to figure out here. I mean, it's not complicated at all. But notice this time we didn't get an ordered pair just to pick the number out of, so we would have to calculate it anyway. But, I mean, you don't get much easier than that. 1/2 all over h. I need to get a common denominator in the numerator. This is something you have to be able to do without hesitation. We've done this a ton, and you cannot just try and block fractions out of your mind. This is equal to the limit as h approaches 0 of, all right, so my common denominator in the numerator is going to be 2 times 2 plus h, which means this numerator becomes 2, and I have minus, this numerator becomes 2 plus h, all over h. So this is equal to the limit as h approaches 0 of, in the numerator, I'm going to have 2 minus 2, so that zeroes out. But then I have that negative h, so I'll have negative h over 2 times 2 plus h all over h. So if it helps, you can think of this as h over 1. I mean, you don't have to write it like that, but at least think it like that. So I know I'm going to have the limit as h approaches 0 of negative h over 2 times 2 plus h times the reciprocal of that, which is 1 over h. So that's nice because these h's will reduce. And I get the limit as h approaches 0 of negative 1 over 2 times 2 plus h. So now that I have that simplified, I mean, if I had multiplied this together or whatever, but I didn't need to, so might as well leave it like that, can evaluate. So when I evaluate it, I substitute in this 0, so that gives me 2 times 2, and I get negative 1/4. And that is the slope. Notice I did not drop this limit notation until I actually evaluate it. That is part of your work all along the way. You choose to get sloppy now because it's on your notes or because it's in Delta Math. That's not going to help you when you get into calculus, guys. What questions do you have? Anything? Okay, you can do this. I know you can do this. All right. So now we're going to look at tangent line equations. All we were doing was finding the slope. We're going to write an equation here. So it says if you know the slope of the tangent line, or we're able to find it like we're about to, at a given point, then you can write the equation of the tangent line using the point-slope form. I cannot stress to you enough how important this form is. Y equals mx plus b, slope-intercept form, it's junk. Unless you are given the slope and you are given the intercept, it is junk. Throw it in the trash. This is your go-to form. I promise you it'll make your life way easier. All right, so let's look at it. So it says find the equation of the tangent line. Well, in order for me to do that, I have to have the slope and I have to have a point, right? So I know how to find the slope of the tangent line. It's with the difference quotient like we were just doing. So let's do that first. We're going to have the slope is equal to the limit as x approaches 0 of, this is our f of 1, oh, it's h, not x, damn. Sorry. I don't know why. I keep saying it too. Oh, I didn't write it again before, did I? H. H is approaching 0, not x. Sorry. F of 1 plus h minus f of 1 all over h. All right, so I'm going to let you work on this sum, and then I'll start it without speaking. Let's see how well you can do all this on your own. So I got the slope is 4. Double check yourself with me when you're done. See if we agree. Let me know if you have any questions, because we're not done with this question, because that's not what it asked us for. It said, find the equation of the line tangent to the function. Well, I found the slope of the line, but I don't have the equation of the line yet. In order to find the equation of the line, I need the slope. Any questions on slope at this point? Okay, so I need the slope, and I need an ordered pair. I know my x value is 1. What's my y value? 3. And it's a positive 3 because this is minus the f of 1, or you can just calculate it, whatever. But that's my ordered pair, right? So when I go to write my equation, it's y minus y1, which is 3, equals m, which is 4, times x minus x1, which is 1, and then I am done. It would be ridiculous for me to go any step further unless I absolutely had to. If I have to set it equal to y, then I can just add 3 to both sides and I'm done. I mean, you don't have to put it in y equals mx plus b form. That's more brain cells you're using and more opportunity for mistakes and bad things to happen. Okay. What questions do we have? Anything? All right. So we've been finding the slope at specific x values or at specific points. We can also use the limit of the difference quotient to write an equation for the slope. Not an equation for the line, but an equation for the slope of the line tangent to the function at any point. At any point. Okay, so we're not writing the equation of a line, we're writing the equation for the slope. And it says, write an equation for the slope of the line tangent to the function. Then after you do that, you use the equation we just did to find the slope of the line at x equals 4. So we don't get to start with x equals 4 this time, because we want to know what happens at any point. So we're going to find the slope. It's equal to the limit as x, as h, my gosh. Sorry, at least I'm catching myself. H approaches 0. H is approaching 0. Well, in this case, I don't have a number to use, so it's f of x plus h minus f of x all over h. So we do it just like that with the x's and the h's. So this is going to give me the limit as h approaches 0 of, so I'm going to substitute in x plus h in here, and I'm going to get x plus h squared minus 2 times x plus h minus 2 minus all of f of x, which is x squared minus 2x minus 2, all over h. Okay. Everybody with me on where all that came from? Now I just got to do my algebra here. So this equals the limit as h approaches 0 of, this right here does not give me x squared plus h squared. It gives me x squared plus 2xh plus h squared minus 2x minus 2h minus 2, and then change the sign on all of that, minus x squared plus 2x plus 2 all over h. Any questions at this point? Not any time to decide you don't want to show your work and get sloppy, things like that, because you're going to lose stuff in here for sure. All right, so I'm going to clean this up. I've got the limit as h approaches 0 of, all right, so, and again, I've got a ton, so I'm going to mark out as I go. I have x squared and negative x squared. Those zero out. 2xh, that's my only xh, so 2xh. H squared, I only have one h squared. Then I have a negative 2x and a positive 2x. Those zero out. I have a minus 2h. And then I have a negative 2 and a positive 2. Those zero out as well. So that's it for the numerator. Denominator is h. That's equal to the limit as h approaches 0 of, I can factor an h out of the numerator. That leaves me with 2x plus h minus 2 all over h. Then the limit as h approaches 0. Those h's will cancel out, and I'm left with 2x plus h minus 2. Okay. What questions do we have at this point? We're not done, but we all get up to here? So it asks me, here's what we're asked to do. Now remember, all of this equals m, right? It's all m. It says, write an equation for the slope of the line tangent to the function at any point. So since I don't have a specific x, that means my x could be anything on that function. So to do that, the a part, what it's asking me for, I'm going to evaluate the limit at 0, which is going to give me that the slope equals 2x minus 2. Because when it's h is 0, I get 2x minus 2. And this is my answer for A. It's an equation for the slope. It's not an equation of the line, but I can pick any x value that works on my function. If x is 10, then the slope at when x is 10, the slope of the curve is going to be 18. Make sense? And then it asks me to find the slope. So the B part, it says use the equation we just came up with to find the slope of the graph at x equals 4. So for the B part, I do m is equal to 2 times 4 minus 2, which is 6. So m equals 6 here. M equals 6 when the x value is 4. So really the only difference between this and the first ones we did is that we keep x in there until the end. You can actually keep x in there until the end on all of them, but I think sometimes it's nicer not to. You have less variables and it just makes it better. But what questions do we have? Anything at all? This is your algebraic way of finding derivatives, by the way. So you start with the difference quotient. You start about derivatives at the beginning of calculus. Tons of algebra, tons of fractions. You have to be confident in that stuff. I cannot stress that enough. So that's definitely something you want to brush up on in the summer if necessary.